To Unit 18, Scratchzilla versus King Block Kong. Okay, this is a game that I made, oh geez, I think it was probably in 2014, 2015, actually 2013, now when I think about it. Okay, so it's been a few years since I put this program together, and the whole premise of the program was a challenge by a student that was saying that you can't make a two-person fighting game inside Scratch. And so in 2 days I put this together, and when I was making this curriculum I thought, well, you know, that was a decent game, and there's quite a bit to learn from there. And I went through and cleaned up some of the code and make it a little bit more streamlined. Then I also left some of the code intact because I realized this is a good opportunity for students to learn and see if they can figure out how to make it more efficient. So this program you're seeing is based upon a challenge from a student gave me, and you're getting the unrefined version in these instructions, which should be good for you because it should encourage you to say, hey, there's better ways to do all this, and there is better ways to do this. However, this way works, and that's a good way to start, especially when you're learning. Now, let's go ahead and check it out so we can see what's going on. I'm going to turn my volume off because there's going to be some background music and some special effects and stuff playing. So it's a two-player game. You notice I use the goes to kind of go through the introduction scenes there, which are our title sequence, and then we have instructions for the players. I just wrote those here in Scratch. Nothing super complex. And we have two players, and I drew the players. Well, hold on, I didn't draw the players. I took all of the images from Scratch, all the blocks, and then I put them together to create these images inside Scratch. And I'm not an animation expert, so I took the blocks and I built them around other animation templates, so that way I could get some decent looking graphics for punching and kicking. Then the background, you can see that's something I cut out of the Scratch blocks. I put that in Adobe Animate to kind of get the, using vector lines here, to get kind of the shadows built into the images, and then the stuff blowing up in the background, that's just all pure Scratch. Those are just red balls flying down, and then I just change the graphics up, make them bigger, then I just shake the city sprite out of here by changing its XY coordinates randomly just by a couple of pixels. Okay, so the players, they're able to move back and forth and jump. Okay, nothing serious. All right, this program is going to run a little slow since I'm recording a video and having an interpretive language running on my computer. So they'll be able to punch and kick. I'm going to turn the first guy away, or girl, whatever you want to call it. And that is this sprite out here, Scratchzilla. Okay, and what I've done is to save myself some time, I copied the costumes from KBK, which is King Block Kong, to Scratchzilla. So they have the same exact costumes, but what I've done is I changed the color shade for Scratchzilla so it looks different. That way I didn't have to go through and redraw two different set of custom animations because I don't have that much time on my hands, believe it or not. So you're able to kick and punch and shoot fireballs through a timer. You shoot those so often. Then you have a shield, and you can duck and hold your shield, and you can duck and punch and kick and shoot fireballs and stuff. Okay, so that's pretty much the premise of the game. What you'll notice is whenever they punch and kick, you'll see these red dots appear at the end of their hands. And I probably should clean up those XY coordinates. I think on the instructions it'll appear better. I've made some adjustments to this. So what's happening is whenever they're punching and kicking each other, to remove the aspect of detecting if they're touching another sprite and removing the aspect of colors, I put these sprites right here, and I left them visible, but you should make them invisible by ghosting them whenever you get your completed product. I didn't put that in instructions because I figured you could do it. So what's happening is whenever you're punching and kicking, these sprites right here called KBK target and SZ target, what they're doing is they're going to the extensions of the costumes where the character happens to be punching or kicking, and they appear at the end there, and then they detect if they're touching the other player. If they are, then they'll cause the sequence of events that causes the other player to get hurt. For example, I come over here and Whoops. Hold on, which button punches? There we go. So I come over here and I punch him. Okay, you can see I'm punching him. And let's use the other character real quick. Alright, so we can see right there, we're punching and kicking. And you can see that up on the variables, their energy slowly goes away. So it's the red dots that actually cause it to hit. And let's move back. And if you ever had to, if you were to have your shield up when somebody was coming, whoops. That was an error there. No big deal. I'm using the revised version that I was experimenting with, so it works a little different here. So we have our characters, and where's the shield? Oh, hold on a second. Let me pause the video while I get this lowered down to the where they'll die. Okay, now we got it under control. I had to pull up the correct version here. Let me remove these variables. You don't need to see all these things. Hide. Hide. And hide. Okay, so let's finish this guy off here. And whenever you beat up the person, we have these random explosions show up, and then the second round begins. Okay? Now this program doesn't run perfect, which is fine. This is just an educational tool. And you'll notice that one of the sprites popped in the front. It popped in the front because I have this in the view where I'm able to actually interact with the sprites by dragging them around and stuff. Okay, and just by clicking on the screen and doing certain things, it can cause errors when your program is running. Okay, so that is pretty much what you're going to be doing inside this program. You'll be making the game. These targets will be the items that look for collision to make any sort of collision. We'll have the fireballs. You saw those shooting. Anytime there was an explosion, we default to a separate sprite to make the explosion, just so we can delegate that responsibility to another object. Then we had the meteors. They're just kind of there for fun in the background. The code isn't really complex for these. It's just kind of a different way of ranging things. The rounds appearing on the screen, that's nothing super complex that you haven't seen. There's really no major concepts. You can go through the instructions and read what exactly this does. Again, I left this else block down here. I left that empty, so that way if you want to expand the rounds or do something else, you could just start nesting in different pieces of script right here. Then the fight message, that's pretty cut and dry, just glides across the screen. Then the Scratchzilla wins. Again, this is a algorithm that requires input from other pieces of information with variable information that allows it to determine who's the winner and loser between certain matches. The live bars that appear at the top, you can't see very well because I started moving stuff around. Let me see. It should be able to reset fine here. So the KBK lives and SZ lives, these change the number of lives for each of the players. Whoops, wrong sprite. Just with the costumes here. Okay, so whenever the costume, say it has 3 lives, it loses once, we switch to costume 2 for 2 lives, and the same thing with 1 lives. And you'll notice everything resetted pretty nice right there, just because I had programmed it, you know, to ensure that everything was layered properly and all the XY coordinates are set in advance. Let's see, what else have we got? The instructions, and I think I made an error on the instructions. I sure did. For Scratchzilla over here, you can't see my mouse because it's hidden. Instead of duck, it should have read block right there. And I could go through and edit that. I'll do that some other time. I'm sure y'all can figure it out on your own. So number 3 on Scratchzilla should be blocking, not ducking, just so you have that. Sprite 9, this is just a black background. I probably could have gotten rid of all this stuff right here, but I put that there just to have a black background completely behind the entire scene. So it's just sitting back there doing nothing. And then the replay button, this will show up at the end of the match, and you click on that and it allows the player to play the game if they want to, or play the game again if they want to. Okay, let's go look at the instructions. There's some major details going on here. Aside from just making the game, actually making the game and using some different strategies to make the game is part of the learning experience with this particular lesson. Okay, so you're going to learn how to duplicate sprites. If you haven't done that before, this is your big opportunity. You've probably done it before, except this time we're going to be doing a little bit different. We're going to swap out some sprites. We had to do this to utilize some of the naming features for variables in broadcast messages, so we didn't lose that information whenever we were doing this duplication process. Also, I'm going to show you a little bit more about the submenu of the broadcast messages. I think I touched upon that in the video. Renaming variables, and then I'm going to show you a very large script, and I'm going to teach you a new term called problem decomposition. And you've probably already done this before, but problem decomposition is just taking something very large and breaking it up into multiple steps. Let's start off with the 4 main submenus for the broadcast message. 1, rename broadcast. So if you were to go into a broadcast block, the hat or the stack block, and right click, you can see the submenus. And right here, rename broadcast. All you have to do is go through, click on that, change the name, and it changes everything that has the same name to the new name that you gave it. It's pretty easy. Show senders, show receivers. I think I touched on this a little bit before. This is a pretty cool feature. So let's say we're here on replay. Let's stop this. And it says when I receive replay, let's right click on this, show senders. So let's see who's sending this to us. Okay, I can look right here on the script or the list of sprites, and I can see that this sprite, which is called the King Kong wins message, actually it also displays Scratchzilla wins message, but that's one sends the message to that. And if you wanted to see, okay, who all receives this message, you can go through and say, oh, all these sprites receive that message. Okay, so multiple sprites are receiving the same message, and you can go through and look at their code and see what they do when they receive the message. Let's see, the clear senders receivers, that's going to remove all the highlighting. That's all it does. So right here, this is all highlighted. We're like, okay, we figured it out. Let's get that off by right clicking and clear sender receivers so it's no longer displayed. I've worked on long projects before with it showing, and it's never really affected my outcome of the project. It's just, you just turn it off for convenience purposes. Okay, in Scratchzilla, we're going to see a very large script. This one's going to start on step 2G of the instructions. This will be the script that controls the walking, and it does some other things such as it controls the duck action. Okay, this script is very large, and the reason it's large is because when we go through it, and you can't see the details because it's been basically I copied it out of the Scratch program in the Photoshop and kind of chopped it up and reassembled it here. But what's happening is it's checking for multiple conditions on each costume change. So imagine all the animation you've done previously where we switch costumes. Here we're checking for conditions, and we're looking for particular items to be true or false. And if those are true, then we allow the costume change to happen. The reason we do this, and I should also mention some of the conditions we check to see if a user is pressing a key. The reason we do this, it gives us an extreme amount of control over the animation of the sprite and allows us a lot of precision if we were to change something. If we were having the character walk and we want to make them stop walking, we take our finger off the key, the player's automatically going to stop walking on that costume that we turn it off. There won't be a situation where you keep pressing the key, then you let go, and then it continues going for a couple more costume cycles in the animation, which, you know, adds a bit of a kind of makes the game look sloppy. This makes it very, very precise, so the animation stops whenever you stop it and starts whenever you want to start it. Okay, and you'll notice in here we basically are doing this condition check for each of the different costume changes. You can see the large conditions or the sections that branch out very long right here. And let's see if there's anything else about this. When you assemble this in Scratch, just make sure you pay attention to the details and stay focused. You can copy and paste a lot of this stuff For example, if you assemble one of these blocks for the costume, and let me roll through the instructions so you can see what that looks like. I'm going kind of fast here. Let's say here we are on step 2G where we start making these functions. We have the if block right here, okay, that checks all these different conditions right here. We can make this one block, and then we can right click on the if statement like I've shown you before, and it will allow us to copy that block, and then we can just duplicate it all the way down as we go through and complete the program. Also, when we're completing this, you'll notice down here in the instructions I have this red line that tells you we're going to complete this section, and then when we move to the next page, which is right here, we're going to complete this function, and we're going to plug that item I just showed you on the previous page into this right here. So again, one more time, we would put this all together and take this item and plug it in right here, okay? And you can see where I zoom in right there, letting you know that. The reason we have to plug it in is because we have a forever loop, and forever loops, once you put them in together or something inside there, it's really hard to expand it, and the best way to build upon this is to create the function as a large block and then to copy and paste it in there. Okay, let's go back to the part of the slideshow I left off on, which was, let's see, duplicating a sprite. There we go. So, duplicating a sprite, let's go ahead and look at that. I'm going to let you pause the video and go through and read the instructions and some of the information here about duplicating a sprite. Instead, what I'm going to do is I'm going to focus on the actual duplication process. So go ahead and pause the video now and read through that so you know some of the details. Next, I'm going to go back through this part right here where we're talking about renaming the variables when we duplicate. So when we duplicate, local variables, as you know, get duplicated and they get renamed to the actual sprite that you just created through the duplication process. Global variables are not duplicated. Okay, so global variables do not duplicate since they're already global. To change the variable, you just right click on the variable name inside the list. Let me pull up Scratch here. So if we had some variables, let's just make a variable, we'll call it local1, and we'll make this for a sprite only. Then let's make one called global1. Make that for all sprites. And what I'm going to do is I'm going to show you a duplication process here. We'll put in a piece of code. We're not trying to do anything here. We're just putting some random information in, just so you can get an idea what's going on. This does not do anything. What I'm trying to do is think and work at the same time. That's not going very well. We're going to create a new message. We'll call, whoops. Okay. So we'll create a new message and we'll call it test message. So there we go. We got a sprite and we're going to duplicate the sprite. And back to the presentation real quick. Make sure I don't miss anything before I go on. Yeah, go ahead and pause the video and you can go through and read this stuff. I'm going to briefly go through and explain what's happening when we work on this so you can see it in action. So pause the video so you get all the details that I don't talk about. So it's very important to pause the video right now and read about the details. And again, right here, I would pause the video again. Make sure you go through and read about all the details of what we're doing and why we're doing it. It'll give you some more information. So pause the video now. And next, go ahead and pause the video again so you can go through and look at what we're doing for this set of instructions in Scratchzilla. Okay, and here now we're going to be working with something called a swap. And this is kind of a term we use in computer science when we swap variable information for objects and for primitive data storage locations. So what we're going to do with this swap is we're just going to use the same concept, except we're going to swap out some objects, except we're going to do that with sprites here inside Scratch. Okay, so you've read a lot about duplicating sprites and all the information. I'm going to give you another explanation, just a
little bit different. So we have our KBK sprite. Let's say we're programming the KBK sprite, and just make sure to pay attention. What I'm putting up here, this is just a bunch of nonsense, okay? But what's important though, is I want you to see the different variables. I got the local one you saw me set earlier, the global one, which is a global variable. We put a test broadcast message in, and then here we just have a XY coordinate go-to block. Okay, down here we have this sprite called temp. Okay, and if you look real close, it's actually not called temp. Temp is its costume. It's actually Scratchzilla. Okay, now if you remember when the demo of the game ran, Scratchzilla was another character that you're going to go through and program. If you click on this temp, you'll notice in its costumes, there's nothing there. Okay, what this sprite's doing is just holding the name for Scratchzilla. And we need it to hold the name because when we program KBK over here, we need to access some of the local variable information from Scratchzilla for our code. Now, Scratchzilla doesn't really exist, just the name of an object exists. However, what's important to know is we just need the name so we can program our sprite. We can worry about the details later. So for example, if I scroll down here and I find Scratchzilla, now I can program this KBK using some local data from Scratchzilla, and I'm able to access its information whenever I need to, okay? If I didn't have this sprite down here, it wouldn't allow me to type in whatever I wanted to, okay? So it wouldn't allow me to use this variable center right here to get the local variable information from that sprite unless I had some sort of temporary location that has the same exact name. Now, what we're going to do is, let's say we've got KBK completely programmed, and we're going to duplicate KBK so we can reuse it. So I'm going to right click, duplicate. So now I have KBK2, which we click down here, you'll notice it's the same thing. If I go over to its data, you'll notice it has access to global 1, but you'll also notice when I click on this, KBK2 has its own local 1, okay, which is the local variable. So it duplicated the local variable so that this object has its own local variable. And let's say I was going to program this. I can just come over here. Let's say we want to go to the XY coordinates of KBK for no reason. I'm not actually looking to program. I'm just showing you that since KBK2 is right here, I can go and access the variable information for KBK because this one will soon become Scratchzilla. Beforehand, what we got to do is we got to come over to this temp, right click, choose delete, and this is important. When you come over here, you'll notice it doesn't delete the name. It allows the name to stay in there. Okay, that's kind of one of the weird things about Scratch, and it's not a written rule. It's just kind of one of those little quirks about Scratch. So now that I've deleted the sprite, the name stays, so I don't have to worry about that. And I can come back over here to KBK and very carefully make sure I spell the same exact name. And if I do, Scratch will automatically detect that this Scratchzilla name matches up with this one, and it will work. So if I run this code, you'll notice that they stack on top of each other. So KBK is, let's see, which one? Where's KBK? Oh, KBK is right here. So if I run its code, it's going to go to the XY coordinates of Scratchzilla, and you'll notice it's right there, right on top of it. Okay, so that's all we're doing with this whole big long explanation of swapping the sprites, but it's important to understand the details and just knowing what happens to your variables, because I've seen multiple students, when they duplicate sprites, they think they have to duplicate the global variables and rename them and do something different with them. That's not the case. Now let's say we do have a global variable and we want to rename it. So if we right click on here, you notice we can't access that information. What we have to do is come over here, right click, choose rename, and let's call it, I don't know, my new globe. All right, click on my new globe and you'll notice it changes right here, and it'll also change over here. The old version of Scratch 1.4 did not do that, so this is a huge improvement for Scratch. Now if we were to change the local variable name, let's just give it we'll call it rename SZ for Scratchzilla. And you'll notice it only changes here on the Scratchzilla sprite. It does not affect what happens over here. Okay, so to summarize what you just saw, what happened there is that we took the KBK sprite, we programmed it, and then we duplicated it, and it became KBK2. Then we go through and delete the temporary sprite, which was called Scratchzilla, and we go through and rename KBK2 to Scratchzilla. And that's all you need to do to get your code duplicated. And if you remember from right back, where'd it go? It was somewhere in here. I had it somewhere in here. Oh, changing the color effect. We'll actually add this block of code to the Scratchzilla sprite once we start programming it. You'll see that in the steps when we get into the program. We'll make sure we point that out for you. Okay, so that is all there is to it for this one. It's pretty complex. However, if you go through step by step, break it into small chunks, take your time, don't rush through because you're in a big hurry. Read through and understand the logic. If you do those things right there, you're going to be very successful with this. You'll get the program working, and you'll be able to expand upon this and do some pretty cool stuff. Okay, so just remember that you're getting some tools here to change your perspective on programming, and that you can go and apply these however you want in the future to create your own products. All right, good luck, and we'll see you in the next video.